the plan that we will be having. So, so base as far as I remember, it was for 17 or 15 days session, and that has been divided among few of the teachers. That I will be taking a few part, Shashi will be taking few part, and Arun will be taking few part. And advance will be coming later. So as I said, so few of the specific parts which so to making your work dynamic, mainly advance is used, and we'll be coming to that later. So this is mainly the coding part in SAS. We have some advanced part also in SAS, but thing is that all these things comes up with a greater cost. So only for this part, the enterprise guide, the cost or the license required is quite high amount. I think it's more than around €1,000. So for that, only few of the specific client or who have a well-established client can only afford for a license like SAS. And even on top of it, if you are working on GUI interface of SAS, then it would add extra cost. For that reason, few of the clients prefer Tableau or Power BI or any other tools like ClickView as a replacement for SAS because it also cut down their cost. Only specific clients who have their urgent need that the data has to be presented in the SAS platform only they prefer all these GUI things in SAS. Apart, including them, the BI part, the platform analysis, and the virtual analysis, or the predictive modeling, this could be done in other tools as well. So coming on to the data part, so SAS actually means statistical analysis system or software. You can say statistical analysis software, and mainly it is designed for data analytics, understanding of data, making a summary of data, or in a way you can say the major backbone of analytics today is SAS. So as more open source are coming up these days, like R and Python, so SAS is still at the most highest demand in the market, but for few of the clients specifically. But as considering for the overall general public or all of the clients which cannot afford a tool or a system like SAS, R and Python are more preferred there. But still, SAS ranks one at the moment in the market among all other platforms and tools. So mainly we are working with here data collections and formatting of data. So mainly the data that comes up is quite unstructured, and we have certain things to work with in SAS to make the data structured and in a particular format, and that would be needed to show the client or to make a good representation of the data. So these are the basic terms and terminology. I think Sashi has provided a homework for all of you to go through first 20 or 30 pages of the notes. So I think you must have all come across these terms and terminologies there. So I think you must be familiar with all this data warehouse and data mart. What are all these things? Just a minute. Okay, so the main thing that needs to work here is what is standard deviation. So I'm not going into this difference between what is system and software because most of you are working in IT industry, and I think this will be quite familiar with all of you. So I'm not going into this. So let's say standard deviation. What is it? So mainly what happens is, let me show you with an example. So what happens is, suppose I have a data and which is distributed like this, a normal Gaussian distribution that I have, and here somewhere here I have the mean value, and standard deviation shows that how much it deviates from the mean. So this is mainly the significance of standard deviation that we have. So I'm considering that my data is normally distributed. So normally distributed means that if I plot a density curve of that population, then I will be getting somewhere like this, a Gaussian curve. So the standard deviation mainly tells me that how much it deviates from my mean. So standard deviation is mainly used to point out what is the variation of my data set, or how it, uh, so let's say this is my mean, so this is my mu, and this standard deviation, this variation, this range, it will be my sigma. The variation from, I know this is not a good drawing, but hope you all can understand. So this is mainly the purpose of standard deviation, to understand the variation of the data that I have. So now mainly working with the data that we have. So when we will be going through the import and export wizard of SAS, then we will be covering the part that how our data can be imported from SAS from different sources. So one of the common sources that we use is CSV file, XLX, TXT, or flat file, you can say, and also there is a ODBC connection thing that is available in SAS. So those things also we will be covering. Also, if you need to import something from a HTML page, XML page, so those things can also be done in SAS, and we will be covering that later. So first thing that comes up is the access part. So how you can access the data. Second is managing data or making a meaning out of it. For example, if I have some data from some other source and I need to merge it or make an explanation between the two different sources of data, I need to have some manipulation done or some managing done on that data. For this, we have this second step, and then after that is done, I need to analyze my data, how it has been distributed. Like I said previously, standard deviation, minimum value, maximum values, uh, the variation of graph. So these are all the things that needs to be analyzed, and then we have to send it out in a report. So SAS is a platform for all of this. You have an import and export wizard, Proc import, export. Then for managing, we have Proc sort, then merge statement, Proc SQL merge statement, all of these. For analyzing that, we have another report like Proc print or Proc summary, or mainly you can say Proc mean or Proc frequency. And for reporting, there are all other tools as well, like Proc report, Proc tabulate, Proc transpose. Uh, so these are the mainly things that are used in SAS. So in a way, SAS is quite structured, more as contrary to R. So R is quite unstructured. That for the same thing, you have various number of packages available, but SAS is quite specific in its work. So if you know you have to do some work, it would be through these packages or this proc or data step statements only. So in that way, it becomes quite specific and quite bit of clarity is there while working with SAS. As I said earlier, so there are many data step statements, proc statements that are used to actually understand the data, uh, uh, implement some management in the data or make some manipulation in the data, and then report it in a different way or as per the requirement. So for that we have a pre-written library, proc, then other statements, smart statement, data steps. Secondly, it is quite flexible in all other operating systems like Windows, Unix. So mainly when you see there is an opening for SAS, you're quite likely to see that there is an opening with Unix interface or Unix operating system that you have to work with. Secondly, GUI part. So as I mentioned, GUI part is there in SAS, but as being quite expensive, clients prefer more other GUI tools like Tableau or Power BI or ClickView as a replacement for SAS BI. And as I said, it can be connected to all other data sources. ODBC connection is there, XML, HTML connections are available in SAS. So let us now go to a SAS program, mainly how it works. So mainly divided with a few parts, a proc step and a data step. So data step is mainly works with manipulating of data, or if you want to make some changes in the data, assign a new variable. That new variable should be having some attributes. For that, data step is used, and mainly this is for manipulating of data. And now after manipulation, if you want to uh, visualize that data or represent that data in a certain format, for that proc step is used. So let me make it clear. For managing, editing, and manipulating data, this part, data step is used. And for representing, visualization, or making a perfect format of the data, this proc step is used. So these are the major two difference between this data step and proc step. And finally, when I know in what way it has to be generated or produced, I can publish it in a report. So one of the definition that has been provided quite clearly, SAS program is a sequence of steps that the user submit for execution, that is data step and proc step. So data step, how it works and what is the working, we will be coming in a few more minutes later. Proc step is similar as I said, only to show in a particular format. So definition for SAS step, here it goes. It is a combination of SAS statement. The SAS step begins or start with identifying keyword, data or proc, and end with step boundary. So there is a particular format in SAS. Let's say it has to start with something like this. Uh, Proc sort or data data set name, so on so on, and followed by a semicolon. So a semicolon should be followed by each and every statement in SAS, otherwise it would comprehend that the statement hasn't ended. So before ending any statement, you have to make it, you have to provide a semicolon mark there. And for ending, so these are the beginning. part. So this is how it begins. And for ending, we have few. So most commonly used is run, and another is quit statement, which is used in proxy. So there are many more begin statements apart from this. So we will become, but mainly the end statement that we work with is run or quit. So most of the time you will come across a run only. Quit is mainly used for proxy. So these are the boundary steps: beginning step and ending step. And also step boundary is, so for example, if a run statement or a quit statement is missing and beginning of a new data step statement starts, so SAS will comprehend that uh, so it will comprehend that it has ended when a new data step begins. So just a minute. So, just a minute. Hmm. So audio is okay. It seems like. Otherwise, I think I was facing some audio issues. So as I mentioned earlier, semicolon is the ending. So for every statement, the statement ends with a dot or a full stop. In SAS, we have a replacement as a semicolon. So if you provide a semicolon, that means that statement has ended, and it is required for each and every step. For R, it was not required because each and every step you can execute it yourself. But in SAS, it has to be semicolon has to be provided. So these are some of the basic syntax for SAS. So let's go through some of the properties that we have. It will start with a keyword and end with a semicolon. So keyword in the sense, as I said here, so a statement, a begin statement is this, like proc, sort, or data step name. Then I can have a set statement. And then I can have the merge statement. And then another step of let's say assign value. So these are the things and that has to end with a semicolon. Otherwise, SAS will if suppose a semicolon is not provided, so SAS will comprehend two statements as single. So these are some basic things that you need to take care of. And also, if any of you are aspiring for base SAS certification exam, then this is the most important questions that comes up in most of the questions there. That if a semicolon is not provided, what will be the output, or how the SAS working will comprehend the code. So one more major thing, unlike R was case sensitive. SAS is case insensitive. So like SQL, MS SQL or any other SQL language, those are insensitive. Similarly in SAS, so data small a t small a will be similar to capital. So one more thing, that multiple SAS statements can be written in a single row, provided they are separated by a semicolon. So whenever the SAS come across a semicolon, it understand that the step has ended, or that data step has ended, or the statement has ended. Otherwise, it would comprehend that it is the same part of the same statement. And single statement can be written in multiple rows, only provided that after multiple rows it has to end with a semicolon. So this is an example to explain you better. So let us understand that what is happening here. So this is a data step statement. So as we said earlier, there are two parts. One is data step, one is proc step. So this is a data step statement. So this is first statement. So this entire thing, starting from beginning till the end, this is one step, and each of this are statements. So it is a step with four statements. So let's understand what it means. Let me explain it here. Data 1 semicolon set 2 semicolon keep msrp semicolon and run semicolon. So this entire thing is a step, and this entire thing are four statements. So these are the four statements that you have. So oh, let me explain you each and every statement. So data 1, so it makes a new data set, data 1. Or it could be existing also, but mainly when this is called, it is mainly working with a new data set. Or if in case if I have to make some manipulation in the existing data set, even that can be done, new or existing data set, and that has to be manipulated. So mainly this is the purpose of it, to see if I can manipulate this one data set. Two, this is my reference data set, which I will be loading to one, and I will be making manipulation of. Keep MSRP. Keep means to keep that variable, and run is the boundary condition. So one more thing that you need to be clear on. So if I am considering row in SAS means observation, and if I have column, then columns means variable. So these are the basic nomenclature in SAS that you need to be clear on. So if I'm referring to any observation, that means I'm referring to that particular row. If I'm referring to any column, that means I'm referring to that variable. And this is how we will be working with the rest of the thing in SAS. So there are few syntax like observation, first observation, and few syntax in proc frequency, that which are the variables that need to be specified. So that's why I wanted to make it clear that rows are equivalent to observation and columns are equivalent to variable. So now here I have proc content. So content mainly shows what is actually the content of a data set. So in contents, we will be covering Proc contents later. So let me only give you a basic idea of what contents actually contains there. So labels will be there, labels that are associated with every variable. Then attribute, an attribute will be there will every, and few other things like post or engine will be there with every uh, data set. So these are the things that will be there. So mainly proc contents shows you uh, what is there in the data set. Proc print will actually print the entire data set. You can limit it using some of the restriction keys like first variable, first observation, last observation, keep, drop. So these are the things that can be used. And one example was out there that multiple statements can be written in a single row, right? So this is an example of multiple statements written in a single row. So this is a single row, and there I have three statements. So one key thing to identify a statement is semicolon. So let me see how many semicolons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 statements. And if I only include the boundary statement or the step statement, then I have 1, this entire, 2 entire, 3 entire, 4. So considering that a run statement is the end of a boundary step, so considering that I have 4 run statement, run command, so 4 steps. So this is a easy way to understand how many steps I have and how many statements I have. So this is as session. So this part will be taken by Shashi today. So uh, I'll be just explaining a slight part of this. So later he will be taking after a few minutes break. So let me just explain this. So mainly we have some of the primary and secondary uh, windows or logs that are available here. So mainly this result, and there is one Explorer. So Explorer, in that we have some of the data sets that are available. Uh, what are the key things are there, and what is the result that has been shown for a given program that has been executed if I need to store it in some other thing. So this is the output window. Log window mainly deals with what are the errors that I have, what are the warnings that I get, and also if or suppose if a macro is declared, or for example if I have to work with a macro and I need to show the values, how it has been generated. So for that log is used. An editor is mainly for actually editing your program, writing your program, making to run it. So these are the key things. So few things that we need to clear on. SAS doesn't stop with a warning. Only if there is an error, it will stop its execution. Warning will be only shown as a mark or a signal. For suppose if I have a variable or a macro variable, let's say, and if SAS is not able to resolve it, then it will provide a warning mark to me, saying that I cannot, that the system cannot resolve, or this variable cannot be resolved. But still, it will keep on executing. But in case if I have an error, it will completely stop executing. So as it is mentioned here, it will be mentioned in green color, a warning, but execution will continue. But if it encounters a error, then it will be marked in red color and it will stop execution. An editor window, as I said earlier, that it is the window where actually I write the program or edit the program, or make any or run the program. So just few more things that we have just to understand the basics. So errors are here mainly of 5 types. So one is syntax error. For example, if you have misplaced some of the syntax, which are the key syntax that needs to be used in SAS, so those are mainly syntax error. For example, if I, let's say I have written data 1 set 2 and so can anyone say what is the error here? What is the issue here? Either in the chat section or you can unmute yourself and speak. Okay. Yeah, correct. Correct. So the first statement is without any semicolon. And as I said, if there is not a semicolon, SAS will consider this to be a part of single statement. So what it considers is data 1 set 2 and run. So it considered this to be a single statement and this to be a single statement. So then problem arises because it cannot locate anything called set and then it is not able to work with it. So this is mainly a example of a syntax error. So this is how a syntax error works because I have misplaced some of the syntax, or let's say if the syntax here I've mentioned something incorrect, then also it is part of my syntax error. So let's say what my notes says about syntax error. So it occurs mainly when the program statements do not conform to the rules of the SAS language. So misplaced or SAS keywords, missing a semicolon, invalid statement option, dataset option, or unmatched quotation mark. So mainly that deals with the syntax. So you must be familiar with some other programming language as well. So syntax error mainly comes with when my syntax is improper or I have not provided the correct syntax. So I'll be covering only the surface part of this errors, and for tomorrow's class I expect you to go through all of these, or even if you're not clear on this, just do a bit of Google and understand. So I will be just covering a surface part of it so that in the next class when I ask you that what are these syntax error or what are the different types of error, you can easily answer. Yeah, Vali, we will share this document. So I think all of the documents has been shared. There is, we will be uploading this in a Google Doc, and there, from there you can access to it. So I think few of the members are still missing in that WhatsApp group, that is SAS 3. So we have created a new WhatsApp group for SAS 3, and some of you have missed or haven't been placed in that group. So if that is the case, then please let us know in that analyst hub group so that we can add you there. So semantic error. So this is occurs when so let's say I have, so this will be covered later in part. So just let me go through an example. So I have an input statement and a put statement. So input, what it will do is it will convert from character to numeric. So one of the mnemonic to memorize is that it is integer. It will converting it into an integer, and for this is put. So let's say this is my function to convert from character to numeric, and I have a put function which converts from numeric to character. So let's say if I need to convert from character to numeric, then what I should provide in that function, character value or a numeric value? Yeah, correct. So for that I need to provide a character value. But in case if I have provided a numeric value, then that would be an error. So these are the kind of, this is an example of semantic error. When there has been some other expectation and you have entered something else. So as I said, I will be only touching on the surface level. So I'm expecting that you all will go through this. Execution error also. So when SAS is actually comprehending the data set and it comes across some error in calculation or say in some missing arguments, then this execution time comes. So one common example for this would be, let's say if I have 10 and I have divided it by 0, then what would be my value? So let's do it in Excel itself. So I'm getting some this value, hash div divided by 0 exclamation mark. So this shows that I have done something error with my formula, or this my formula is invalid. So this is an execution type error, something similar in SAS. Another is my data error. So let's consider this example. So I have a data age and I have input. Input is in the format of name and number, and it has been mentioned that my name is a character, so it has been followed by a dollar sign, and number is numeric. So in SAS, it's a nomenclature that always if a character variable is there, it will be associated with a dollar sign, and if a numeric is there, the dollar sign would be absent. So if you need to comprehend that, you can comprehend it in that way. So name is associated with a dollar sign, it is a character, and number is alone. That means it is a numeric. And data lines, and that means these are the data that will be provided in the dataset age. So data line will read, and this data will go into age. So how it will read? So first of all, I have a character variable Sue, and followed by a numeric variable 35. So it has read a character and a numeric in name and number respectively. Now going to next line, Joe, and followed by XX. Here it has expected some numeric values, but it has come across some character values. So there it is an error. It is not able to read, and it will provide a missing value in the age. So let's say if I have it like this, Sue who is 35, then Joe, if I provided it sex, and then Nathan 34. So in the data line, what will be the output? Be like this. Sue will be 35 because it has went as expected. Joe will be uh, as it is, but the number that is associated with it will be a dot, and Nathan will be 34 because everything was correct about this. So one thing need to clarify here as well that a numeric missing value is denoted by a dot, and a character missing value is denoted by a blank. And here in SAS we have only two types of variable. Either it is a numeric or it is a character. So the variables like date, time, these are all part of numeric variable only, but only represented in a particular format or in some other format. That we will do later. So this is part of a data error. So data was expected in some other format and we have provided in some other format. And last one I think is the macro error. So macro related error will be covering later in the advanced SAS part. So one thing as I mentioned, SAS is only two variables. Either it is numeric or it is character variable. So these are few of the characteristics of numeric and character variable. So let me give you an example here. So this is a tab. So one difference you can note it here that when I have written something in character, it has aligned itself towards the left. You can see that character has assigned itself to the left, and this numeric has aligned itself towards the right. So this is the main behavior of a character and a numeric variable. That this is left aligned and it is a right aligned. So as I said, numeric is a right align and character is a left align. Numeric can have a value from 0 to and also can be preceded by plus and minus sign. So if a numeric is preceded by plus and minus, or if a decimal is there, that should be treated as a numeric. And also the missing value is denoted by dot, as I said earlier. For character, a missing value is denoted by a blank. So default length is 8. So there are few functions in SAS, like find or something else. So if anything numeric comes up, the default length that is assigned to it will be 8. Character is itself 8. So these are some of the basic differences between them. The last thing is naming convention. After that, we will go to the interface of SAS and we will explain you how it works and how the interface looks like and what are the tools and techniques that we have at our disposal to work with it. So these are the some SAS naming conventions that are there. So as I said earlier, if you are aspiring for some certification in SAS, then these are the things that you need to mug up or memorize it by heart, because these are the few features that come up with and these are associated with most of the questions there in certification. So these are quite simple. Name can hold a maximum length of 32 characters. First thing. Second is it should begin with an underscore or a letter. It should not begin with a numeric. And second onwards, so from the second letter onward, it could be a underscore, a letter, or a number. Special character like slash, punctuation marks, those are not allowed, or those are not accepted as a valid SAS name. And as it has been mentioned earlier, all the names, steps, functions in SAS are case insensitive. So these are the few basic things. So let us now start with the interface of SAS and let us explain how it works. So just give us 2 minutes, or you can have a 2 minutes of break and then we can start. That is because I have muted myself. So as I said, so I needed some 2 minutes to set up this. So, so this is mainly the interface of SAS that we have. So this is a bit older version of SAS 9.3. So currently we have SAS 9.4, and this is the main log version. So here all the errors or all the warning that will be displayed here. So the notes. So this is the main log part that I showed you just now. This is the log part, and here all the notes, warning, and error message will be displayed here. And as I said in the this main uh, uh, coloring convention that is associated with each and every attribute, notes will be showed in blue color. Warning will be showed in green color. But the thing is that with warning, uh, the execution won't stop. It will keep executing the statements, but it will be only displayed as a warning that these are the variables that were not able to be resolved, or we have been stuck, or there has been a problem with resolving these of the variables. Error mark is with red, and at that stage, the program will stop executing whenever it comes across an error. And these are all the main things that are displayed in log window. So here I have got editor window. So editor has there two options. So here I have yeah. So two options I have: enhance editor and program editor. So program editor can only be shown once only, and then enhance editor can be used n number of times. So if I need to create more of them, I can do that. So main purpose for making so many advanced enhanced editor is that using this I can run many programs simultaneously, and that will be the feature that will be available with the enhanced editor. But that is not the case with program editor. So for a specific work or a specific dedicated work that I need to do, I need to work on program editor. Otherwise, I can always work with enhanced editor. And this is the run statement that I have. So for example, if I have made any data set, or if I'm working with any for example, data, then uh, L, L equal to 6 and run, then I need to select all of them and then I have to run. So this is actually will be ठीक है So run, submit. Then in log it will show actually how it has worked. So as I said, blue note will actually show that what are the nodes that are there. So if any issue was there, it would have been shown in either green or either in red, but it is not. So let's see what is there in the output window. So output won't be there. It will be shown in the libraries that I have. And one more example that I need to show, that these are all the permanent data set and work is on the temporary. So the one which I worked in, that was a temporary uh, data set. So it will be stored in work. So this will be covered later tomorrow. So this is one. So one here I have only one variable, that is value, and value is equal to 6. So I have only done with one. For this reason, value equal to 6, that has been stored there. So just give me 2 minutes. The window has been closed, so I need to set it again. So just 2 minutes.